All right, I'm back. Here's number 21. L'Hopital's rule, if I plug in 0, e to the 0. Here, let me make sure I'm doing this right. Oh, I forgot a lawn. Did I forget a lawn in there? Where's the lawn? Oh, I took the lawn of both sides. Huh. There's a lawn in there. So e to the 0 is 1 plus 0. So ln 1 is 0. This is 0 over 0. I just wrote it really improperly. Let me write it properly so that you can see it better. All right. That's written better, so you can see it. So when you evaluate at 0, e to the 0 is 1 plus 0. So ln 1 is 0. So it's 0 over 0. All right, take the derivative. So this is going to be a fraction. So it's e to the x plus x. Then the derivative of that is e to the x plus 1, and then over 1. And now I'm going to evaluate again at 0. So e to the 0 plus 1 is 1. E to the 0 plus 0, 1. So this is all this, it looks like it's equal to 3. So 2. So e to the 0 is 1 plus 1. So that's 3 times 2. That's going to be divided by 1 plus 0. So that's just 1. So this, all of this ends up being 3 times 2, which is 6. And then to get y by itself, that's what y equals from the very beginning. So the answer is e to the 6th. 22. The limit as x approaches 0 from the right, 1 plus x over 1 over x. Didn't we do this one? Not quite. Okay. So if you evaluate it, we're going to do the logarithm, make it equal to y. And then we're going to do the logarithm to both sides so that we can do the power rule. And to write it with the power rule, 1 over x, that goes in front. We're going to write it as a quotient or a fraction. If you evaluate at 0, it's 0 over 0, so it's L'Hopital's rule. So this is a fraction over 1. Evaluate at 0, that's just 1. So that's just e to the 1, or e. Another definition of what e equals. 23. Two more like this. So you know what we're going to do here? We're going to make it equal to y and take the logarithm. That means the power is going to go in front. So if I look at this as a quotient, it's going to have ln 2 plus x over x. So this is going to infinity, this is going to infinity. So it's L'Hopital's rule. So we're going to take the derivative. I can also tell this, that the bottom is going to increase faster than the top. So this answer is going to be 0. So I don't really need that. So when I know a logarithm is slower than just x, the right-hand behavior here, the answer is 0. And so the answer is e to the 0, or the answer is 1. Let me see where I have the pen. So the answer number 23 is 1. All right, 24. And number 24 is the limit as x approaches 1. Again, you should try it. Ln x to the 1 minus x. So again, we're going to do logarithm here. So y equals, but it's the logarithm. Oh, put that in front. We need to create a quotient. So we're going to write 1 minus x to the negative 1 to create a quotient. If I plug in 1, the answer is 0 over 0. So I'm going to do L'Hopital's rule. So it's that over 1 over x. Here, it's negative 1 minus x, negative 2 with a hook of negative 1. So if I plug in 1, and rearrange it, it's still indeterminate. But I'm going to rearrange this. So a negative times a negative is positive. So I have 1 over x times the reciprocal. All right, so there it is there. If I plug in 1, it's still indeterminate. So again, I'm going to do L'Hopital's rule again. This is a tedious one. So the top, and then the bottom is the product rule. The first times the derivative of the second plus the second times the derivative of the first. So we have negative 2, 1 minus x, x plus ln x. So if I plug in 1, all of that for 0. Because 0 plus, or 1 plus ln 1 is just 1. So it's 0 over 1, which is 0. So that means y equals e to the 0, or 1. Man, that was a lot of work to get to there. All right, enough of that. 25. So the limit as x approaches infinity, e to the x, subtract x over x squared. So the right-hand behavior here, the top compared to the bottom. So because the top is increasing faster than the bottom, this is going to infinity. Or you can say it doesn't exist. 26, the limit as x approaches infinity, ln x over x. Because the bottom is increasing faster than the top, this is 0. Oops, what did I do? Oh, this was A and B. Sorry, A and B. 26, just type it in your calculator. You have this wonderful calculator. Type in the limit as x approaches 1.5, 2x cubed minus 3x squared minus 8x plus 12. Just type it in, 6x cubed minus 25x squared plus 34x minus 15. So press menu, calculus, limit, type it in, go control, divide to get a fraction, just type it in, take your time, and then the answer at the end should be 7. believe it or not. All right, I'm going to do a part 3. Mr. G Math, over and out.